All right. Okay, so I've got 2:35, so I'm going to get started here. This is COMP2404 Introduction to Software Engineering. And yeah, I'm Daryl Hill. So this is, we are here on March 15th, the Ides of March, right? So assignment 3 and tutorial 7 are due this weekend, right? So hopefully you guys are well on your way to completing that. And I will probably, yeah, so I've read over assignment 4 spec. There's a bunch of mistakes, so I corrected those. I'm going to wait till tomorrow, read it again, and then hopefully release it then. And there's bound to be mistakes left over. So, you know, don't be afraid to bring them to my attention. That is sort of the software engineering experience, is getting a specification where some things are ambiguous, or so you have to clarify things, or you have to point out mistakes. Also, don't be afraid to solve these problems on your own. I try not to penalize anybody for doing that unless you do it in a way that, you know, is explicitly against what we're trying to learn. But for the most part, if you're creative in a solution, or if you make a design decision, I'm okay with that. I would even encourage it. Just, you know, maybe add something to your README file saying what you did. Yeah, so yeah, that's about that. Yeah, so you have to make sure the specification is exactly right. So when you feed it into ChatGPT, you get your complete assignment, right? I don't know. Has anybody tried that? And nobody wants to admit it. That's fine. I would be very interested to see the results. I haven't tried it, but I know there's a new version of ChatGPT out now. So yeah, I don't know, who knows? We might have to change our teaching style going forward. I don't know. But yeah, any questions before we pick up where we left off? Okay, so yeah, we started overloading last class. We're going to continue with this class. Operator overloading, that is. So what is, we left off talking about operators and user-defined types on these operators. Sorry, one sec. I think. Yeah. So by operators, we're generally talking about, well, lots of different things, but subscript, less than, greater than, equals, assignment operators. There is the arrow operator, the dereferencing operator, and we can make all of these things work with our user-defined types, right? So if I have two students, Matt and Joe, well, a lot of sort of legacy code and a lot of things like a vector are designed to, if I wanted to sort, I had a vector full of students that I wanted to sort, well, by default, it's going to look for the less than operator. Now, this doesn't always work if we're sorting pointers. And you can always override this and pass in a function in order to sort, but, you know, it doesn't hurt to have a less than operator anyways. So last class, we were looking at this time class, and we had made this equals operator, right? So it returns a Boolean, and it has this specific function signature, the operator keyword, followed by the type of operator, followed by the arguments, and then const if we want. So basically, it is just a function. We cannot change, we can change the return type if we want, that's fine. We cannot change the number of arguments, however, right? So that is sort of, when C++ goes looking for a double equals, it looks for something on the left and something on the right. And the something on the left is whatever time object I'm currently calling that on. And the thing on the right is the one that I pass in. So those things we can't change, but there's some things we can change, and we can, of course, change the implementation. So when we made the equals, we simply had a convert to seconds function, which takes the current time and converts it to seconds past midnight, basically. And then uses the double equals for the integer to compare these two time objects. So if they have the same number of seconds since midnight, then these represent the same times. And so we implemented that, and then we ran it, or did we run it? I can't remember if we got that far. And I'm in the wrong place. So we made two time objects, we printed them out, and then if we run them, we get the first time object is 5:45, the second time object is 12. And then is lunch equal to wake up? Well, wake up is 5:45, lunch is 12, and the answer was no. And we called that function by using the operator syntax. So the compiler went through, it saw this, and then it starts looking for things to, because there's a bunch of places actually where it could find one of these functions. So it starts looking for them, and it found one in our time class. All right. So incidentally, if I did not have this, let's say I did something like this, and so I called, it might give me an error, but so it gives me an error, but if I try to compile it, I'm going to get a huge error because the compiler by default has a bunch of places it can look for this function. So when we get into operator overloading, these types of errors are going to become normal. If you get the argument types wrong, or the signature doesn't match because one is const and one isn't, right? So these are common. If I call this operator function inside of a const function, then that better be const. Otherwise, it's not going to call it, right? So yeah, get used to, if you see something like this, it means your signatures aren't matching, or it can't find this particular operator function. But in our case, yeah, it seems to be working so far. So we know that these are not equal. We can check to see if two times are equal. So we can check, for instance, if wake up is equal to itself, and that should return true. Okay, so is lunch equal to wake up? No here, but we should have that. Is wake up equal to wake up? And that is yes. Okay, so our double equals seems to be working. Yeah, so that's basically where we left off last class. Questions before, yeah? Brighter? Are you having? No, but I can maybe shut these lights off. Is this the class where it's locked away? Might be. Yeah, so the problem with this class is that the light controls are in that booth, and I have to call. So yeah, I'll try and make the screen brighter and see what happens, I guess. Yeah. How do you make the screen brighter in Windows? Is that here? All right. Brightness. If it's a real problem, I can call tech support. Does that help at all? Does that look better? Does anybody not read that? Okay. Okay, so yeah, that still kind of sucks, but if it is a real problem, I mean, I'll call. I can call them. They'll be down here in maybe 5 minutes, probably. But yeah, I can't access that room, unfortunately. All right. Okay, so we're doing a little bit of what's called test-driven development, and what that means is that in my main function here, I put a bunch of function calls that I want to have work. And I give some output and I know basically the output I want. I mean, I could have written these more completely and said, I'm expecting this should be yes or this should be no, but we basically know what it should be returning. So let's continue with this. So now we want to make this not equals operator. So I'm going to check if wake up is not equal to lunch. And this is going to be a very similar function. So I'm just going to copy this. So we have the same return type, the same basic signature. We're just going to change the operator type now. And then, oops. Can copy and paste this. And now what I'm going to do is, I could just use the not equals here, but I'm going to actually start relying on functions that I've already made. So I'm going to say this double equals t, and then I will say, right, not this. This might give me some trouble. Okay, so now I'm relying on this equals operator that I've already written, and I'm saying, well, this not equals function should return the opposite of the equals function. Okay, so that is sort of a common way to make these Boolean comparison functions. Now, of course, now I'm doing 2 function calls instead of 1. So if you're really trying to be efficient, this might not be the best way to go about it, but for our purposes, it'll work fine. Our error is gone away here, and okay, so is lunch not equal to wake up? That is a yes here, so that is true. Okay, so now we have 2 comparison operators, and let's make some more. Yeah, actually, let's test this the other way. So this is, I'm saying, is wake up not equal to itself? And the answer is no. Now there's like a double negative here. So this means wake up is equal to wake up. So this returns false, which means this should output no, which is what we wanted. Okay. So now let's do a less than. So again, it's going to be very similar to this. It takes, we're just going to change this to a less than, and then over here, we're going to again rely on our convert to seconds operator to make our life easier, or convert to seconds function. So this time is less than the time that I passed in if convert to seconds is less than t dot convert to seconds, right? So simply just changing them into the number of seconds since midnight, and then comparing them by using the integer less than. All right, and now it's giving me trouble. What is the problem? Oh, I'm missing this. Yeah, it's supposed to be commented. I'm just, yeah, right. I uncommented too many. Okay, so is wake up less than lunch? Was that the, should be. Yeah, so wake up versus lunch, is it less than? Then the answer is yes. Okay, so that's working well. Now I can do the less than or equal to. So this is the less than or equal to operator. Again, I'm going to take advantage of existing operators and existing signatures. So I could simply follow this example. I can use convert to seconds here, but maybe this is actually quite complicated, and maybe this is actually quite complicated. So I kind of want to start relying on, I've already done the work for writing the less than and the equals. So what I'm going to do here is simply call on those. So this is technically a less than or equal to operator. So I can say return this equal to t, logical or this less than t. All right. Okay, so that seems to be working. So I'm relying on code that I've written already. Again, it's pretty simple. I could have just used the integer comparator. But if this was a more complicated operation, for instance, my less than, maybe I compare the hour and then the minute and the second, and it could be way more complicated than that. So just to simplify it, I can do this. All right, my main function, I have less than or equal to. And I forgot to save something, or what did I do? I went to the wrong one. Yeah, here we go. Okay, so wake up versus wake up, is it less than or equal to? The answer is yes, which is consistent with what we should be getting. Okay. Okay, questions so far? All right, so easy stuff so far. All right, so let's do the rest of them. Now we want greater than or equal to. Geez Louise. Greater than or equal to. And again, I'm going to be relying on functions that I already have made. Okay, so greater than or equal to, it's similar to this, except I can now swap this for greater than. And my greater than function, I can actually, I mean, it's fine if I do this, or I can call, I can say this less than or equal to t, and then it's greater than if it's not, if this is not less than or equal to t. So it's just, again, there's sort of very simple logical operations that, you know, this is sort of 1805 stuff and how we derive these things, but yeah. So what do I have now? Just about everything I want. And then in my tests, okay, so I have a greater than and a greater than or equal to. So let's check those. Forgot to save. Okay, so wake up versus lunch. Is wake up greater than lunch? The answer is no. Is it greater than or equal to lunch? The answer is no. Yeah, so less than or equal to is yes. So yeah, these return the correct results for these. I could do more thorough testing, but I think that's sufficient for now. Yeah, so that basically tests everything. Just for fun, we'll run everything else. Okay, so yeah, wake up versus lunch, is it less than? Yes. Less than or equal to? Yes. Wake up versus wake up, is it greater than wake up? Is it greater than itself? No. Is it greater than or equal to? The answer is yes. All of those are the results that we should be expecting. So yeah, that's basically operator overloading, in this case, simply for these comparison operators. They all return a Boolean. Of course, we can change the return type, but by default, they return Boolean. If you use a different return type, you might get some sort of error somewhere, right? Somebody tries to call a less than and tries to use it as a Boolean. You might get a surprise. So it's best to stick with the expected roles of these operators rather than trying inventing new roles for them. But yeah, questions? Okay. All right. So that is the Boolean operators. And for your assignment 4, you will be overloading those for the date class, I think. So very, very similar to what we just saw with the time class. You can do that with the date class as well. Okay, so yeah, just a review of what we just looked at. Basically, when the compiler sees something like this, it converts it to something like this, or rather, that is one of the places it looks for this function. It also looks at 100 other places, as we saw. So we can also, of course, we have all of these other operators as well. And really, you only need this double equals and the less than, and then we can create the rest of the operators. Now, we don't get those for free. We still have to make them. Yeah. And also, if I'm reusing some of these operators in my functions and I need to access the current object, then I'm going to call on this, but I'm going to dereference it first because I'm comparing objects, not pointers. All right, so yeah, operator overloading, why bother? Well, as somebody mentioned, language consistency is a big one. So back in the day when, in the 80s or whatever, that C++ was starting out, seemed like a really good idea. And then that's sort of been, well, everything has to be backwards compatible. So that sort of hangs out with your language for the rest of its life. So basically, users of your class will probably expect it. Now there's, in modern C++, there's ways to get the compiler to generate these for you, but, we will practice writing them first, and then you can take the shortcuts later. So code readability, right? So these operators, all we're familiar with them, even outside of programming, if we've done math or anything like that. So also consistency is important for polymorphism, right? So as mentioned, the vector class, I can pass in a custom function in order to compare two things. But if I don't, it's going to, by default, use the less than operator if I try to sort a vector of things. So in general, these provide a nice general common interface so that every different type that I store in my vector can be sorted. Yeah, so by default, collections use these. And in fact, I think you really only need this and this to sort, or sorry, less than to sort, and this equals for find if you want to do something like that. Yeah. Okay. So for example, the string class provides all of these operators, and we've relied on them in some of the past assignments, right? If we stored things in alphabetical order by title or by name, then we used the string dot less than or greater than operators. In order to find, we use this, the string double equals operator. You may have used the subscript operator on a string. Simply returns a character at that location. And we've definitely used the stream insertion and extraction operators. So yeah, these are all overloaded for the string class. It is sort of expected for, I mean, I'll qualify that. It depends on what you're working on, but in general, it's not unexpected for you to overload or override these operators. Some of these get overloaded for us, right? So we make a time class or whatever class. We don't implement these, but they're implemented for us in order to do things like return the address, a sequencing operator. We get a default assignment operator. At this point, we're going to start overloading it because, well, by default, this does a shallow copy. So if I want to use the assignment operator, I'm going to run into the same problem that I did with the copy constructor if I have dynamically allocated memory, so memory on the heap. So this is the old rule of 3 or rule of 5, depending on, what you're implementing. But if I do override the default copy constructor in order to do a deep copy, I should also override this assignment operator to do a deep copy. And yeah, one of the problems we mentioned before, if your object has a constant member variable, this assignment operator, the default one, gets deleted. Now you have to write your own because the compiler does not know how to reassign a constant, right? So it doesn't know what it should do there. So it just says, it's up to you now to write your own assignment operator function. Okay. Yes, so we also have explicitly overloaded operators. So some operators don't have default functions, but we decide we can implement them. Our time class did not have those comparison operators by default, but we added them. Almost all operators can be overloaded, almost. But each operator must be overloaded separately. Again, there's sort of an exception to this. You can write, as mentioned last class, you can write a compare function that compares an object to an object of the same type. It returns negative if it's less, right? So this returns an int. And it returns a negative int if it's less, or 0 if they're equal, or a positive integer if it's greater than. And you can ask the compiler in some modern C++ compilers to just generate all of the operators that we just wrote ourselves. Right, so, and then equals and not equal. All right, so each operator is actually syntactic sugar for a function, right? So this, although it looks, it doesn't look like a function, but it really is. It's calling a function. And we can actually, if we wanted to, just explicitly call this function name. This will work, right? T equals, and then I pass in another time object that will work exactly the same as this. Okay, so yeah. Now, when I have a operator, in this case, a binary operator, it takes 2 arguments. So I have T compared to T2. The left-hand side operand, in this case is T, is the calling object. So if I wanted to access the T member variables, I would use the this keyword, or I could use the this keyword, or you could just access them directly if there's no collision. The right-hand side operand is the second parameter. Sorry. Yeah, second parameter technically. All right, let's call this the first parameter. Makes a little more sense in this context. Right, so here I have only one parameter, and that is the right-hand side operand in this particular function. Now I can overload this double equals operator as a global function. We did it as a member function, in which case this changes a little bit. But for now, this is, we'll stick with member functions. Member functions, this is your first left-hand side operand, and the parameter is your right-hand side operand. So we're only allowed one explicit parameter in this case. All right, so as mentioned, we can overload our operators as global functions or as member functions, but not both. Okay, so yeah, global functions are, well, they're not really to be avoided. But we generally prefer member functions if we're writing object-oriented code. But sometimes with operators, they have to be global. And we'll talk about why very shortly. But some other limitations of operators, we cannot change the operators for primitives. So 2 + 2 will always give 4 on a computer. I can't overload this operator to do something different. or if I had a float or a double, that's a fixed function. I can't change that. We cannot create new operators. The compiler won't recognize them, so we're stuck with the list of operators that we have. We cannot change the arity, so we cannot change how this works, right? So the plus operator will take a left-hand side operand and a right-hand side operand. However we choose to deliver those operands, whether through a member function or a global function, it's always going to have two arguments. So we have to use the conventional syntax and arity. The only flexibility you get is the return value. But yeah. So you cannot change precedence or associativity, right? So this means 2 plus 2 plus 3. Well, that's all handled left to right, right? So I add 2 plus 2, I get 4. And then I add 4 plus 3, I get 7. But it's done in that order. If I have something like 2 plus 2 times 3, then I get the order of operations, right? So 2 times 3 will be done first, and then we will add 6 to 2. And that applies if I overload these operators for my defined types for a time object, let's say, then, if this is T2, T2, and T3, well, T2 times T3 will be executed first, and then that will be added to T2. We don't get a choice in that. And some operators cannot be overloaded, right? Some of them are too important to how C++ operates, like the dot operator, the scope resolution operator, the conditional. So this is this one here, right? So where I have a Boolean value and I return, for true, I return this guy here, and false, I return this guy, and a few other ones. Okay. So some operator rules. So we should always enable cascading where possible. And in general, if you're not sure if you should enable cascading, you want it to behave the same as an integer operator, right? So if A, B, C, D are all ints, then this will work, right? This will compile and this will work. It will first assign 0 to D. It will return D, and then it will assign D to C. We'll return C, and then it will assign C to B, and so on. So that's called cascading, which means we can combine a bunch of different function calls in a single line with these operators, which is a nice, makes for some elegant code. Yeah, and the rule is if integers do it, then you should do it with your class, or that's the convention. Okay. So in order to enable cascading, we're going to be using this keyword if it's a member function, right? So this is an object's pointer to itself, and it's passed in implicitly to all member functions in your class, right? So in Python, if you write a class function, you actually pass it in explicitly, right? So you have a self parameter that you can define in your list of parameters. That means that I am passing in this object into this function. Yeah, this does not, of course, include static functions. Static functions don't get any this because they do not have any object associated with them. So we can use this explicitly or implicitly. Implicitly means I just leave it off because there's no naming collision. Explicitly means I, use the arrow operator. Okay, so cascading, we talked a little bit about it. It's chaining together member functions into a single statement. So how does it work? Well, the member function returns the left-hand side operand object, right? So now we're just talking general functions now. We're not talking about operator functions. So for instance, if I have a time object, I would want something that looks like this to actually work, right? So what's this going to do? It's going to take time. It's going to call set hours on that. It's going to return the same modified time object and then call set minutes on that. And it'll return that object again and then call set seconds. Okay, so let's see how we are going to override or overload these functions. Okay, so all right, so we have our time object again. We have set hours, set minutes, and set seconds. Did I not? Yeah, they're all implemented. So we used to have a set time function that did all of these together, but now they're broken down into these individual function calls, right? So now I can set the hours independently of the minutes, independently of the seconds. And so, yeah. All right, so we declare 3 time objects, and we will just start by printing them out to make sure they work, or at least printing out the lunch. And let's see. Okay, so printing lunch happens at 12 o'clock, and we declared them here with no arguments, and then we set it here. And this called the set, set hours, set minutes, set seconds. Okay, so everything's working so far. Now, again, using our test-driven development, we will define a line of code that we want to have work. We can see right now that it's giving us an error. So it says expression must have class type, but it has type void. So the compiler recognizes that we're trying to do cascading, but it's saying, what you're doing is not really working for me. So what we're going to do is change the return type. So what we want to do is in our set hours, for instance, after I call this function, I want to return this, right? So after I set the hours, I want to return this object. And why this? Well, because here I continue to use the dot operator. So I should return an object and not a pointer. So when I return it, I should dereference it to make sure that this is an object. And then that means what I'm returning is a time object. But if I return by value, it's going to make a copy, right? So what I want to do is return it by reference, right? This is the same thing as parameter passing. When we did parameter passing, if you simply pass a time parameter by value, then it just makes a copy when I pass it in. If I put it by reference, then it passes in the use that object directly. Okay, so set hours here, time reference. And yeah, and our return types, so we haven't talked a lot about return types. Again, they act a lot like parameters. So if I pass return by value, it's going to a copy will be made. Well, only if you assign it to something, but that's a little bit of a compiler thing. We don't worry too much about that. And if I return by reference, then I return the address. So I am also able to return by const reference, and I should do that in some situations, but not in this one, because after I set the hours, well, first, yeah, it's complaining here, but I want to be able to return this time object and then call another function on it, say set minutes, right? So the purpose of cascading is that I still want to be able to modify this. So I want to return a non-const version of this time object. And then I could do the same thing for the rest of these. So you should all return this, which is, yeah, and by reference. Oh, yeah. Okay, so I have, yeah, so now this, the errors are gone, so it looks like this works. My test-driven development case is working so far, but let's make sure that it prints out 12, 30, and 45 seconds. So yeah, so printing lunch, 12, 30, 45. So my cascading worked here. All right. Questions? Okay. So yeah, the important part is to remember to return by reference to enable cascading and not make it a const. We want to pass the original object back and still be able to modify it. Okay, and then we should also probably do the same thing here. Which means that I could actually change how this is done. I can just use cascading here as well. And make this a time object. Okay, so all of our errors are gone. So yeah. So what that means is that I can do something like this. I could say changing lunch and printing. And so instead of making that into a separate call, I can just tack on the print function point at the end. And then, yeah, that should do functionally the same thing. Okay, changing lunch and printing, and then we have 12, 30, and 45 seconds. Okay. All right, questions so far? Okay, so now we can see the next test in our test-driven development is cascading with this operator. Sorry, assignment operator. Okay, so we want to make a assignment operator. We do want to enable cascading, so we know we have to return a reference to a time object. Equals, this is going to take a time object that we're not going to modify, so we can make this one const. And the assignment operator does modify the underlying object, so we do not want to make that one const, right? So none of these are const functions with good reason, because we are making changes to the underlying object. Okay. Okay, so do I have a set time that takes a no. Well, I have this set time which I can use. So I can just say set time t dot hours, t dot minutes, t dot seconds. And actually I can return it in the same at the same time, right? Because this is already set up for cascading, so I can simply set the time and return it, and that will work, or should work. So let's test that out. So we're changing supper to be equal to wake up to be equal to lunch, which is now at 3:45 and 15. We're sleeping in, I guess. But yeah, let's print some of those. And lunch.print. Okay, so we changed lunch. We changed all of our times to be equal to 3:45. And then we did something wrong. CC. All right, dot H. Definition of implicitly declared. Oh, so it doesn't, what the? Oh. No. Yeah, I don't know. Make clean. Const expression. All right, well. Yeah, did I forget to, am I changing the wrong file, maybe? Time. Hmm. Always something. No declaration matches. I don't time.cc 39. Did I not save that one? Oh, it's not saved. All right, geez. Okay. I must have been looking at the wrong one. Okay, so now we enabled cascading with the assignment operator, and all three times are now equal to 3:45 and 15 seconds. Yeah, so that is this. And again, if we did deep copies in our copy constructor, you want to do a deep copy here as well. But, you know, and then all this other fancy stuff where we enable cascading and so on and so forth. All right. I think that's it for this. Questions on that? Okay. All right. So this is overloading operators as a member function. That's what we've been doing so far. When we're done, we're doing this, especially with binary operators where we have two operands. The left-hand side operand is the this object, so it's the current object. And then the right-hand side operand should be passed in as a parameter by reference. It can be constant reference if you want. It doesn't have to be, but not by pointer. So whenever possible, we want to implement these operators as member functions. It makes sense in terms of object-oriented programming and encapsulation and all of those good things. When we start to have to make global functions, then we have trouble with visibility. Well, it's going to be public. However, sometimes we have to do it because C++, well, when they decided to overload operators, they ran into some problems. So sometimes an operator can't be a member function of a class because, well, my left-hand side object maybe is a primitive, or maybe it's a class I don't have access to, right? I want to do things like, I want to compare two students, let's say, but maybe I want to, or let's say I have a time object. Maybe I want to say, is 2 equal to this time object, right? So maybe this makes sense in my context. I want to be able to compare an integer to whatever my time object is. And then let's say if my time object is equal to 2 in seconds, right? If my convert to seconds function returns 2, then this should return true. But now my left-hand side operand is an integer. I can't make a member function for the integer class. Well, 1, because it's not a class, but 2, because even if it was a class, I don't have access to it. Somebody else wrote it. All that stuff is private. I can't make those changes. So there are these situations where we have to overload these operators as global functions. So when we do it, let's say we wanted to compare two students, and we're going to overload this equals operator as a global function. Well, now both students become parameters that we pass in. Before, the left-hand side operand was this, right? So we dereferenced it and had access to the members and things like that. But now we're going to pass both of these in explicitly. Of course, this causes a problem with encapsulation because, well, now the private member variables of these two students are not accessible to this function. So of course, this is where friendship comes in, right? So this is a legitimate use for friendship. By the way, you probably should not be using friendship on your assignment 3. If you are, you're probably doing things wrong. If it's the only way you can get things working, then by all means do it. It's better that it's working than done correctly, but maybe think about trying to do it some other way. So this is the only permitted use of friendship in the course, is to help these global functions operate correctly. Okay, so let's take a look at example 4. Okay, so we have again our time function. It's the same one we've been looking at. None of the operators are there. And as mentioned, well, maybe it makes sense to compare our time to some integers. So if lunchtime is at noon, that is 43,200 seconds since midnight. And breakfast time, if that's at 5:45, that's 20,700 seconds since midnight. So it might make sense. Well, first of all, I can compare wake up equal lunch. Lunch is an integer. Wake up is my time object. So this particular operator can be added as a member function, right? Because the left-hand side is my time object, which I'm writing. So I'm going to overload that as a member function. Now, the difference here is that I'm taking an integer, and I can make this const as well. I'm taking an integer as an argument instead of a time reference, right? So actually I can overload this equals operator for any type I want, right? So if it's a student, for instance, and I want to check if I pass in a string, maybe that's equal to a name. I might want to check to see if the name of my student is equal to whatever my parameter is. In this case, we'll use integers, but we're certainly not limited to that. Okay, and we still have our convert to seconds function. Oh, this should be const. So we can simply rely on the convert to seconds equals t. Okay, so if this time object converted to seconds is equal to the integer parameter that I passed in, return true, otherwise return false. So yeah, that's this implemented as a member function, and let's give it a spin. So cd. All right, so these are the types of errors you can expect. Let's see, did I forget to save something? Yes, forgot to save that one. That one's okay.